You can almost see a light at the end of the tunnel for derivatives, because after this video, you should be equipped with all of the knowledge you need to start applying the derivatives to the wild. As a recap, we covered that when you take the inverse of a function, call it g of x, and find its derivative, it then becomes 1 divided by the derivative of the original function of the inverse function. Specifically, we looked at what happens when that inverse is ln of x, the inverse to e to the x, and established that derivative to be 1 over x. Let's jump right into these derivatives with the inverse sign, also called the arc sign by some instructors. We apply the same formula for inverse, with the derivative of the original function, sine of x, being cos of x. We now get that our derivative is 1 over the cosine of the inverse sine of x. What is the cosine of the inverse sine? We tackle this problem by constructing a right-angled triangle with a hypotenuse of 1 and an opposite side of x, so that to find theta, it is the inverse sine of the opposite over the adjacent, which becomes the inverse sine of x. So we now just call this term theta. Now that the angle is known, the cosine of theta is the adjacent side. Using the Pythagorean theorem, we can solve for cosine of theta, and it becomes square root 1 minus x squared. Plugging this information into the derivative formula, the derivative of the inverse sine of x is 1 over square root of 1 minus x squared. For inverse cosine, we do pretty much the same things, except now it is the sine of the inverse cosine we need to know. We construct a similar right triangle, but this time the adjacent is x instead of the hypotenuse, so that the angle theta is inverse cosine of x. Now the opposite side is sine theta, and solving it using the Pythagorean theorem leads us to the fact that the sine of theta is square root 1 minus x squared. Plugging this into the derivative, we get that the derivative of inverse cosine is negative 1 over the square root of 1 minus x squared. So it's the negative derivative of the inverse sine, which is kind of cool. Lastly, for the inverse tangent, the same formula for finding derivatives of inverses is used. But the derivative of tangent of x is the secant squared of x. Finding secant squared of tan inverse of x is pretty much the same as finding cosine squared of tan inverse of x, since secant of x is just 1 over cosine of x. So yet again, we draw out a right triangle, but this time it is the ratio of the opposite to the adjacent that is equal to the number x, so that the angle theta can become the inverse tan of x. When you flip the secant squared term in the derivative using the 1 over cos of x identity, then it becomes clear that the derivative of the inverse tangent of x is cos squared of theta, replacing tan inverse of x with theta. Well, on this triangle, the hypotenuse is square root of 1 plus x squared using Pythagorean's theorem. So the cosine, the ratio of the adjacent to the hypotenuse, is 1, the adjacent, over square root of 1 plus x squared, which is the hypotenuse. When you square this cosine, you are left with the fact that the derivative of the inverse tangent of x is 1 divided by 1 plus x squared. As a refresher, here are the 3 derivatives written up on the screen. Feel free to jot these down if you need. To wrap things up, here's an example derivative. If f of x equals the inverse tangent of 1 over x, then what is the derivative? Well, using the chain rule, the derivative of the inner function is negative 1 over x squared, and the derivative of the outer function is 1 over 1 plus 1 over x squared. After you simplify things, you get that the derivative is negative 1 over 1 plus x squared. So it's the negative derivative of the inverse tangent, which is also kind of cool. That finishes up the last 3 derivatives. In the next video will be filled with examples of problems that involve taking derivatives. Until then, keep on learning.